So we've got a nice graph here, x equals 2 cos theta, y equals 2 sin theta. That's a circle. I've just drawn it between theta is between 0 and pi. And I want to know what that area is, and I want to use my parametric form. So what would it look like normally? In Cartesian form, it would look like this. And we're just going to use the chain rule as always. We use the chain rule a lot, and we're going to say that dx is equivalent to dx by d theta. And then what we're going to do is use integration by substitution, usual method. Everything's going to change. We're going to do a substitution, and everything's going to be in terms of theta. So we need to substitute in the y. That's easy. We need to substitute in the dx by d theta. We need to substitute in x is minus 2 in terms of theta, and x is 2 in terms of theta. So what's our integration going to and from? Well, at this point here, where x is 2, then we know that if x is 2, then 2 cos theta equals 2, which means cos theta equals 1, which means theta equals 0. So that's that top limit. Ready to change? That's changing to a 0. What about at the other end, when x is minus 2? If x is minus 2, then 2 cos theta equals minus 2, which means cos theta equals minus 1, which means that theta equals pi. So this one at the bottom is going to change to a pi. Okay, y, what's y? That's easy. Y is 2 sine theta. What about dx by d theta? That's pretty easy. I can differentiate x. Dx by d theta, see if I can squash it in here, is equal to minus 2 sine theta. Minus 2 sine theta. Okay, let's rewrite this a bit more nicely. So we're going from pi to 0. Oh, that's the wrong way round. Don't worry about that. Normally we have the lower one at the bottom and then up to the higher one, but don't worry, we can swap it in a minute. Then we've got 2 sine theta. Then we've got minus 2 sine theta d theta. Okay, what I can do is pull the minus 4 out, and actually I can swap the limits round and change that minus to a plus. Turning the limits round creates a minus sign, because if you go from a to b and then integrate and get f, then you're going to do f of b minus f of a. And if you swap those limits round, so you put a b down here and put an a down here, then what will be different is you'll have f of a minus f of b, which is the negative of f of b minus f of a. So that's why it produces that minus sign. So if you want to swap your limits, go ahead, but you introduce a minus sign there. Okay, and then inside I've got sine squared theta d theta, and we all know how to integrate this. It's one of your basic ones. It's a half 1 minus cos, and then you double the angle. So this is 2 theta minus a half sine 2 theta from 0 to pi. Stick your limits in and you're going to get the area shaded. So in summary, what do we do for parametric integration? We're starting off with the idea of it in Cartesian form. X is going from a to b, y, which is a function of x, dx. Then we use the chain rule to change dx into dx by d theta, and then we do integration by substitution. We change that and that to what theta is, we sub in what y is, we sub in what dx by d theta is, and then we integrate.